Hello guys, welcome back to my channel Code with Matt. So today we are going to start with another topic. It is the process. So in this video is not like cover whole about the process, but I will have another video where I will talk more about the processes. But in this video I am going to giving you idea, and we will talk much more in detail about processes, how they communicate with each other, and what uh, do we need, why do we need to learn more about processes and operating system. Okay, so let's start. So as we know that process is a programming execution, and process is a active state, and the program is a passive state. Program is a set of instruction, and when it is executing, then it is known as process, right? Yes. So this is called process. So when we create a process when we start a computer, right? When we start a computer, there is only single process in it, right? But as soon as we started doing we started doing work on our computer, then other process is getting created, which means it becomes a tree-like structure, right? It becomes a tree-like structure, and all the processes in a computer that it is currently executing is is in a grand tree, is in the form of a grand tree, is it children of some other children, right? Okay, so the first process that is created is init process, and all the other process is the children of this process, right? Which means they need they need to communicate with each other with some form, and we will talk about it later, right? So a process forms a tree-like structure, right? If we have created a process, it can create other child process also, right? Either these child process can share the resources of the parent process, or they can have their independent set of resources. Okay, now when we create a process, when we create a process, then what are the details? What are the details that system needs to know? And what happens when when a process is created, right? So uh, now let us suppose there is a case when you started a video editor app, and you gave a video to it, and you tell it it is in .avi, right? It is in .avi format, or whatever it is. Okay, and you wanted to convert it to .mp4, right? And you gave this process to the video editor, right? And as like it would take about 1 hour. Let us suppose it will take about 1 hour. So are you going to sit 1 hour and watch this process to be completed? No, right? You minimize this, and you started working on some browser. Okay, you started working on some browser, and other than working on the browser, you might have also enabled the notification of some email, right? So that process is also working where you are fetching the emails, right? So currently there are three processes that is working. Firstly, this one. Secondly, you're working on web browser, and thirdly the email one, right? Yes. So are these working simultaneously, like on a single core? On a single core? Obviously not, because when uh, uh, when when we run a processor when we run a process at a particular instance, only one. only a processor can execute only one process, right? Processor can execute only one process at a time. If if this process has completed its time of execution, then it needs to be switched. It needs to be switched with other process, right? Let us suppose, this process is currently processing is being done on this process. Now, let us suppose that the time limit, uh, like there is assumption, there is a feel of there is a placebo effect going on in front of us, with which is done by the computer, which is done by the operating system, is that all the processes that is doing, that is being done on a computer is not on a single core, is not being done simultaneously, but it is done with in a particular time period. This time period is also known as time quantum, right? And this time quantum is so small that it appears to us it appears to us as they are working in simultaneous way, right? So we need to save, like let us suppose it is 1 second. Let us suppose that it is 1 second. It is not that small, but for us to understand, let us suppose it's 1 second. So now let us suppose as we have already know that this process require 1 hour. So of one the processing of 1 second needs to be saved, right? So that other process can come, and when this process comes later, it should resume working where we left, right? So that's why we have some registers associated with it. Okay, we have registers associated with the process and whatever the work which has done. The registers associated are like program counter and stack pointers, right? Okay, so when we create a process, we have two things. Firstly, it's address space. Firstly, it's address space. Okay, so it's address space, and then secondly, the process, an entry in process table. Okay, this is the process table and entry in process table. The process table, process one, two, three. This is the process ID. So the process table identifies the processor points to PCB. And what does the PCB stores? PCB stores the set of resources associated with it. That is, what are the resources that the currently executing, or this particular process. This particular process is having access to the registers. That is the program counter and stack pointer. The information in that registers when it was executing, right? And then the list of open files, which files that it has opened, with this process has opened, and list of related processes, right? So the PCB contains all these details, and uh, yeah, and then the process is having its own address space. So this address space, what does it? Its address space is storing the address space is storing the executable program and the program data, right? And its stack, it's a heap, right? Executable program, uh, and executable program and data that it requires, the global data or whatever. This heap section contains the dynamically allocated memory, and stack contains the temper stack contains whatever I have told in my earlier video, that the function calls another function, and it stores the function argument, the return address of the function, and the function parameters and all about it, right? So all this is contained inside the is contained inside the address space of a process, and the operating system maintains process table which contains which contains which points to the PCB, right, which points to PCB, and program control block which contains the details about the list of open files, and registers, uh, details of the registers, like whatever detail which is required for a process to be stopped and switched to other process. All the details is being contained inside the PCB, right? To save the context of one process and load the context of another process. And saving the context means the saving the latest details in PCB, saving the latest details in PCB, right? So this change in the process is known as context switching. As I have said to you, saving the context of one process and loading the context of another process is known as context switching, right? Yes, and also the main memory is limited, right? Main memory we have is limited. So the as if a process is getting executed, then its address space is inside the main memory. So you can say that the address space shouldn't be greater than can't be greater than, like it should not be, but it can't be greater than the size of the main memory, right? uh, Size of the main memory, because it won't be able to load into the main memory, right? But if like we have there is a scenario then where we are playing GTA San Andreas or large games in our computer, but the RAM is very less, 2 GB, 4 GB, right? So how is this possible? This is possible with with the new technology called virtual memory, right? Virtual memory. We'll talk about it later. We'll talk about it later. But this is all about the processes, the memory it takes, and what do we, what does the operating system do when process is created, right? So thank you for watching this video. Uh, do subscribe, like if you like the video, and comment if you're having any doubt. Thanks. Bye.